why do I need to use HTTPS, right? Well, today it's simple because the cool APIs that enables the progressive web apps feature are behind HTTPS. Browser vendors, not just Google, requires you to use HTTPS in order to get these APIs. So things like Service Worker that we just talked for the past two talks, you have to have HTTPS site in order to even use Service Worker APIs. And you know, it's like encrypted, secure, it's a powerful API, you need to use it over HTTPS is a regular like explanation when it comes to these talks. But then like when I was a web developer, in 2015, I watched a talk from one of my colleagues now, talking about this new thing called Service Worker, who is going to be, it is going to be amazing and you should do it. And I was like, okay, cool, I'm going to do it. And then I just quickly realized that you have to use it over HTTPS. And I was like, why? All I wanted to do was making my silly app logo fine. It doesn't ask for user's identity. There's no login feature. I'm not asking for credit card information. Why do I have to make my website HTTPS? The thing though, well, so people say like, oh, those are powerful APIs. You have to use HTTPS. Like, why? But once I investigated why, it got me a little more like understandable that I could understand why it is behind HTTPS. So if you're accessing non-secure, like flat HTTP site, it's like sending postcard in public, right? So the data you are exchanging between your browser and server is like flat text. Anybody can read it, and if somebody who is kind of like have a bad mindset and wants to do the harm to your user or your server, can, you know, rewrite over it and then send it. Like if you think about it, it's amazing that you send a postcard and you can be sure that the postcard is like not manipulated by your, I don't know, mailman or like your neighbors. It's kind of like that. Like it is visible to anybody. It's just like, you know, nobody look at it. It's just hidden behind the protocol, but like it is actually readable. When you do the HTTPS though, it's kind of like sending a secret letter. So like, I can't really like come up with a good analogy for this. So like, let's just imagine there's a magical sunglass that you and your receiver have to have. And you can only read this letter if you have this magical set of sunglasses. Right? So HTTPS is like a secret letter. It's encrypted, nobody can read. If somebody wants to do the harm on your postcard, they cannot like read it, they cannot change it. And then on top of that, it gives you that like certificate of like this postcard is definitely from Bob to the house. So those are the basic explanations, but how does this magical sunglass or this like encryption comes to play, right? Like, if I access unknown website, I haven't spoken to this website yet, so like how do I establish this like secret messaging system? Before going into that, on the little tangent, I need to explain to you how public key cryptography works. And then we can explain how things work. So, public key cryptography is a base of crypto where you encrypt with public key, and that encrypted message is only decryptable with private key. So if you're a web developer and if you wanted to connect GitHub, say, from your command line, you may have followed the tutorial of like, do this thing to make an RSA key, and then on the public key, copy and paste that to here, and like, don't change anything. And that was me like 2 months ago when I didn't know how this works. I was just like following the steps of like, whatever the text generated and like putting paste into it. But what it's really doing is that creating a set of two keys, public, that is like to be public, used by somebody else, and then the private. So when somebody uses your public key to encrypt the message to send it to you, that encrypted message is only decryptable from the private key, which you hopefully kept it in your laptop or computer near and dear to your heart and never shared with somebody else. Okay, cool. Private key cryptography. So, when you were to make the HTTPS special sunglass, you go through this, a process called TLS handshake. So it goes like this, and we'll look at it in like a technical term but first with stick figure. So browser says like, hi, I speak RSA, which is a type of public key cryptography, or DSS is another one. Like, which one should we communicate first? And this is just like telling them like, hey, let's like start a conversation and like, let's do it secure way. So like, which one do you want to use? And service is like, oh, okay, let's use like RSA. Here's my certificate and here's my public key. Please use this key to encrypt the data for the next message, right? So the browser goes in to see like, okay, cool, I got the certificate. Oh, by the way, server can also ask certificate for the client if server wants to do that verification. But the client now has a certificate, the client verifies the certificate that that's legit, and then use that public key to encrypt the pre-master secret and send it over to server again. So what pre-master secret means is kind of like a seed, like a same seed, to create an encryption key. So this is like the same origin start, and you use this seed to create the science. It's a weird analogy. Anyway, but because it starts from the same seed and use the same procedure, and the seed is encrypted, you who sent the seed and the server who received the seed, which was encrypted and then decrypted with their private key, you two are the only one who has the same one, which means you two are the only one who end up in the same encryption key. And once those keys are established, then the client says like, okay, let's move on to like secret language, and then services are cool, let's do that too. So that's how the HTTP starts. Recap, HTTPS, again, those APIs are behind HTTPS. And understanding that how it works in the postcard analogy, to me, as a web developer 3 months ago, finally makes sense to me why those powerful APIs are behind HTTPS. You don't want to receive a service worker file which will control your caching and your intercept your network request to be manipulated by somebody who is attacking you. Like, you want to make sure that the service worker file that you are receiving is the file that the server sent, that you trusted. As you as a user trusted that the site will send you, not complicated, not bad code from google.com. And when google.com says that they're sending you the service worker file to control the caching strategy, then you want to be sure. So it has to be go through HTTPS. And the same goes for get user media. Like, you don't want somebody else who might be trying to harm you take control over your media or your camera access or push notifications. So hopefully that makes sense that everything is behind HTTPS and why you have to use HTTPS. So needless to say, HTTPS is a crucial part of your user experience. Like, it will provide you user peace of mind that you are sending the thing that you want to send and nobody can change it. But also, it is a key piece of a key to unlocking those powerful features that provide better user experience. So let's talk about things you need to be careful when you're moving over to HTTPS, when you start using HTTPS. 3 things I'm going to cover: performance, cost, and how to maintain, like how to move your existing code base or existing sites to HTTPS. So let's talk about performance. So you might have heard somewhere online that if you move to HTTPS, load of your site, loading time of your site will increase and your site becomes slow. In a way, it is true, but there is a trick to minimize that. And then there is a new protocol to gain those loss back dramatically. Let's talk about that. So when you're doing regular, like let's say your site moves to HTTPS and user access the site. Let's see what happens. First, user might request a non-secure HTTP site, or http:// your website. And server needs to respond like, oh, sorry, we moved to HTTPS site, so please redirect to the HTTPS version of the site, right? So client receives that 301 header and access, okay, now I need to access to HTTPS site. And they go through this process of creating a sandbox, right? We call it TLS handshake. So these two round trips are exactly how I describe, like, hey, let's talk to secret lingo, hey, here's my certificate, let's like make a sunglass, and then, you know, hey, I finished it, let's talk to the secret lingo, and then back. Like, it adds 2 more round trips in order to establish the first connection of like, give me index HTML file. So there's 2 points that might slow down the request. The first is computational costs of computing the encrypted key. Takes time and resources of the server or the machine. Fortunately, the modern hardware is so powerful enough to handle this on CPU. And you don't really need to buy extra set of hardware or like wait for that computation to be over. So likely, in modern web development, this is a less of a concern. Another one is more permanent, is additional round trips. If you think about it, if you're on the flat, non-secure HTTP, you would just ask like, hey, let me get index HTML, and then server will be transmitted to HTML. But when you move your site to HTTPS, then you have to do this like, oh, first redirect to HTTPS, and then in order to establish the connection of HTTPS, you need to do 2 more round trips to establish that connection. So there's additional round trips that take time. And there's a few tricks to minimize these 3 round trips. Let's look at the first redirect one. So this is a little more straightforward than the other 2 to minimize it. It's called HTTP Strict Transport Security, or HSTS. This is basically server putting in the header the hint of like, hey, thanks for asking for my site. Oh, by the way, my site moved to HTTPS. So for next 1 month or however long you set it in there, only access to my site and all of the subdomains in HTTPS. And client saves that data so that next time user types on your site again, it will know, oh, server already told me that they move it to HTTPS, so I'm gonna directly go into HTTPS. So that's 1 round trip saved. So let's take a look at the other 2 round trips that happens in order to establish a connection. Is there possible to minimize those? So if you look at this, client is waiting until that TLS handshake establishes. Like, the client have to wait until server says like, hey, I'm ready, before they can send get me index HTML request, get request at the bottom. Turns out, you don't really have to wait for the server to get done on the last step. You can like just ask for the thing, and that's called TLS full start. So what happens is that client says like, hey, let's speak HTTPS. Server says yes, this is a certificate, and then you do like preparations, and then when you do that, let's talk. You said let's talk HTTPS. Oh, by the way, here's my request. And you don't wait for the server to come back like, yes, let's talk HTTPS. And you don't have to wait for the server to finish, but you can send the request before. And this is the setting in your server. So if your server supports TLS full start, then you should enable it. Another one to minimize this round trip is TLS session resumption. And this is like kind of like a client's way of like, if the client, browser, and the server spoke TLS before, meaning like if you're connected to the server over HTTPS before, then client can send the session ID of the previous TLS connection. So it's like saying the client is like, hey, we've spoken TLS before, do you remember me? And then server says like, oh, I remember you, let's pick up the conversation from there. And they can start the HTTPS connection immediately. So those are the 2 things to handle. But each of those connections are still 1 by 1, like waiting for the reply to come back. And keep in mind that if you are opening a 6 connection with the server, means there's going to be 6 connections to do the TLS handshake. In HTTP2, you only have 1 channel between client and server. And the communications are stream and multitext, which means on the request, client will send the request of like 2 different files on the one stream, and then tag it of like which one is which request, and then server can get the data back in one other stream too. And it does one other cool thing, which is indicated in blue box. So when client requests, say, index HTML, if you're writing a server code, you know that client requesting index HTML means they will have certain font file that you coded inside of your HTML or some static image that will never change. Server knows by having those index HTML file that like, oh, those subsequent requests are definitely coming because I told them that's the resources, right? So server can, in HTTP 2 protocol, server can do things like, oh, here's my index HTML file. By the way, you already requested index HTML, which means you might need those font file too. And then they just like push the data even before the client asks for the data. So HTTPS or HTTP 2 makes things faster. Weather.com moved their service to HTTPS. And when they initially launched, they saw 150 millisecond hit for the TLS negotiation. So their site load got slowed down. But a month later, they implemented HTTP 2, and overall, their load dropped for 250 millisecond per page view. So even though it initially got slower by moving to HTTPS and introducing the handshake, by using HTTP 2, they gained much more time back on the load. So let's talk about the cost. In talking about cost, two things comes into my mind. The cost of buying certificate and the cost of kind of like effect that does to your search ranking, especially if you're maintaining media site that the traffic is important. Those are the two costs that comes with it. So let's talk about certificate. When you're using HTTPS, as I mentioned, you need to have a certificate, and you buy those certificates from certificate authority. Traditionally, it costed a lot of money, but not the case anymore. So the site like SSL Mate, for a long time, has been offering standard SSL for $16 per one certificate. So even if you need a multiple one, or if you need a like even fancier option, that shouldn't like it. Newer project called Let's Encrypt will give you a certificate for free, so you don't need to pay for anything. Both of them provide a command line interface to update or manage your certificate, so you don't have to worry about running out of the certificate and expiring it. So I use Let's Encrypt. You have to renew it for my personal site, because it's my personal site, I'm not making money from it, so I was like, okay, let's use a free one. You have to basically hit one command every 6 months to renew it, and I have that command in cron job on my server to like hit every 6 months, and that's just autopilot money. But it's encrypted. Let's talk about search ranking. When you introduce or when you make HTTPS version of the site, you might think that, ooh, that sounds really bad idea for SEO, because traditional word of nugget, like wisdom of nugget, is that like you should never have one same site in the two different places, right? And HTTP and HTTPS is treated as two different things, even though your domain name is the same. So Google in particular have recommendations, and I'm sure other search engines have too. If you move to HTTPS, then you should make sure that every HTTP, the non-secure request, gets a redirect to your HTTPS, the secure version, so that the search engine knows that, oh, this site permanently moved to HTTPS version. And if you're a front-end developer, you should also make sure that in your markup, you have a link cloud canonical, which basically assures the caller that like this version, HTTPS version of my markup is the canonical link. Please use this one. And it's kind of a hinting that like this is the destination we want you to be. There's a bunch more recommendations about when you're like thinking about search ranking guidance on the developers.google.com/web. So if you are in charge of those things and worry about those, I highly recommend using those. So let's talk about the maintenance. Finally, you covered, you're sure about the performance, and you are like you have peace of mind that it doesn't cost you much. Now what do? I have existing code base and existing services that just needs to move to HTTPS, but I have no interest of like refactoring whole bunch of stuff or starting over, right? What do I need to do? You need to ask that, does your third-party dependency support HTTPS? Because when you move your site to HTTPS, all of your resources, including the third-party dependencies that you use, needs to be over HTTPS. So what kind of things that falls under this category? Well, the first one is advertisement. If you make money from advertisement on your site, then your ad has to be served from HTTPS. In Google's case particular, the AdSense and ad network, it's always served by HTTPS. So, you know, even without you noticing it, it's over HTTPS. But it's not just a Google thing. So in 2013, IAB, Interactive Advertising Bureau, did the survey of the member company, and they found out that nearly 80% of the delivery systems support HTTPS. And in those published report blog posts, they also underscored that they are committed to make this 100%. So it's not just a Google saying like, oh, a network is the secure thing and you should use it. No, it's not the case. Industry-wide, they care about HTTPS and moving to HTTPS. So ad shouldn't be the blocker for moving your site to HTTPS. Another one is this is a hard one to say, and I recorded this talk in front of video, and I took it for like 100 takes. Paper or header. So let's say you are running the site, and you make a partnership by sending traffic to other sites. Traditionally, that's done by referrer header on the HTTP request. So, like if your link, you have your site and where that referral came from in the header. If your HTTPS site, a secure site, and sending the traffic to non-secure HTTP site, then the browser will strip this information. Because when user is communicating with the server or the service over HTTPS, those URL might be sensitive information, and we don't want to expose that. So that will strip. So does that mean I can't have a partnership deal? What do? Well, refer our policy to the SKU. So this is a web platform standard that is proposed and supported by many other browsers. And basically let you say to the browser that, hey, for this link, when a user clicks on it, let's just relax that policy a bit and send the domain name of my site. There's a bunch of policy rules. In this case, origin went plus origin, but on the documentation side, there's a bunch of different variations. If this different policy is set, then browser will send the domain name of your site, but not the specific URL. So that at least your the partner who is receiving the traffic knows that you sent the traffic to there, but they cannot know where exactly user was at, and kind of protecting user's privacy. Another one is mixed content. So if you are, let's say, a news media, and you think about all the images and iframes that you have on your media, gazillions number of articles, that is from third party. And you need to make sure that those contents, even the static images, are served by HTTPS. That's kind of pain. Yeah. So this is the topic. This is one topic that deserves. Wait. This is one topic that deserves more than the 30 minutes talk, so I'm not going to get into how, but you should, if that was the case for you, then you should check out content security policy, which will guideline you how to deal with those situations and how to monitor that won't happen in your site. So when you are doing migration to HTTPS, in Chrome Dev Tools, for more than a year, we have this panel called security. And this will make you much easier when you're investigating mixed content issues or certificate issues. And if you are working on it, this is really helpful panel to look at. So the takeaway from this talk, HTTPS protects the users, give them the peace of mind that they're talking to the server, the service that you actually provided. And HTTPS is required for some core APIs that enables PWA. And when you migrate into HTTPS, you kind of need to plan ahead. You can't just flip the switch and everything's going to be good. You need to be careful about how to move to HTTPS. So, if you are interested in, or if you are the person who's tasked to move your service to HTTPS, here's more recommended leanings. Pretty much anything, because as I mentioned in the beginning, I was like, hey, I want the security. So pretty much anything falls under /fundamental/security, you can just bug me on this Twitter handle. Thank you very much.